Hello students, in this video lecture we are going to learn the protection of alternator. We know that alternator is also known as DC generator and is a costly and important machine in the power system. It has a prime location in the power system. It has many associated systems such as prime mover, excitation system, cooling system, voltage regulator. Therefore, protection of main generator and its associated system is a complex one. As it has a paramount importance in the power system, it is necessary to provide all types of protections irrespective of the cost of protection required. Now, generally, the generator protections are broadly divided into stator winding protection, field winding protection, and protection for other associated systems such as prime mover, mechanical systems, thermal systems, etc. Now the generator protections are because of various faults, and let us see what are the various faults occurring on the generator. The first one is the stator winding faults. These include the phase-to-phase fault, phase-to-earth fault, stator interturn faults. Then the second part is the field winding faults, the rotor interturn faults, earth faults, that is conductor to earth, loss of field protection, field separation. Now, what are the other faults? The failure of the prime mover, unbalanced loading, thermal overloading, faults at the bearings, external faults, and overspeeding of the prime mover. So, students, in this way, we have learned what are the faults taking place on the alternator. Now, let us see what are the abnormal conditions and protections to be provided for the alternator. Let us start one by one. The stator faults, phase-to-phase faults, it is provided by, or the protection provided is biased differential protection. Phase-to-earth fault, sensitive earth fault protection is used. For the interturn fault, the interturn fault protection is used. Now, second is the thermal overloading, and that is continuous overloading and failure of cooling system. Because of this, the overheating of the stator winding takes place and there is a failure of the insulation winding that may result into earth fault in the winding. Therefore, for the continuous overloading, the stator overload protection with overload relay is used. Now for the failure of the cooling system, we have to sense what is the temperature of the winding, and for that we have to use the thermocouples. The resistance thermometer should be embedded into the slots of the stator. Now the third abnormal condition is unbalanced loading, and unbalanced loading, that is because of unbalanced loading, it results the negative sequence component of the current, and therefore it is necessary to use the negative sequence relay for the large generator and overcurrent relay along with earth fault relay for a small generator. Now the next abnormal conditions are in the rotor earth fault that results into magnetic unbalance, damage to the shaft and bearings, and therefore it should be protected by using the rotor earth fault protection system. Now loss of field. Loss of field means loss of excitation, and because of loss of excitation, the synchronous generator runs as a induction generator and it draws the heavy magnetic current from the infinite bus bar, and therefore the field failure protection should be provided for such a protections. Now the next one is the loss of prime mover. Because of loss of prime mover, the synchronous generator runs as a synchronous motor, and instead of delivering the power to the infinite bus, it draws the power from the infinite bus, and therefore directional reverse power relays are used for its protections. Now over voltages. Over voltages, the effects are because of over voltages, there is a chances of insulation failure, and therefore LA, lightning arresters, are connected to the near to the generator terminals. Now the next abnormal condition is the overfluxing of the generator transformer unit and auxiliary transformer. We know that BM is flux, that is the BM is proportional to V by F, that results into the higher eddy current and hysteresis losses which hits the core, and therefore V by F relay should be connected in the voltage regulator circuit of the generator. Now the next one is the under frequency. The results are the failure of blades of the steam turbine, and therefore we have to use the under frequency relay. Now over frequency relay, why this happens? Because of the loss of load. Nowadays, because of the coronavirus and lockdown in the India, there is a uh, the electricity boards are facing the over frequency problems, and we have to use the over frequency relay for its protections. Now students, we will turn in this way. We have learned what are the abnormal conditions and what are the its effects and which protection is to be provided. Now let us see the Merz wise protection of the alternator. It is also known as biased differential protections, that is used for the transformer, and it is also similarly used for the alternator. Now for the alternator, see, if the alternator winding is star connected, then cities on both sides of the winding should be connected in star like this. And say this is the circuit breaker used here. And if this generator winding or alternator winding is delta connected, cities on this side should be connected in delta, and cities on the right side of the circuit breaker is always connected in star. So in this way, we have seen how to connect the cities for the differential protections. Now here the neutral point is earth as shown, and the restraining coils are connected at the midway of the pilot wires, and the over operating coils are connected from the neutral to the midpoint of the restraining coil for every phase. Now this such a kind of protection used for the alternator having rating above 1 MVA, and it is the differential protection responds only for internal faults and not for the external faults. Now we will stop here. Students, we have learned what is the alternator, its importance in the power system, then the what are the related auxiliaries, the fault, and generally the generator protections are broadly divided into stator winding protection, field winding protection, and protection for the other associate such as the prime mover, mechanical system, thermal system, etc. Also, we have studied the various types of faults taking place in the various parts of the alternator. We have also learned what are the abnormal conditions, what are its effects, and what kind of protections is need to be provided. And lastly, we have seen the differential protections, which is used for the protection of face-to-face fault protections of the alternator, which is also known as biased differential protection, and it is used for the alternator having rating more than 1 MVA. It responds only for the internal fault and not for the external faults. Also, we have seen the city connections. If the alternator is star connected, cities on both the side of the windings are connected in star, and if the alternator is delta connected, cities on these sides are connected in the delta, and cities on the circuit breaker side, that is the right side of the circuit breakers, are always connected in star. Okay, here we will stop. Thank you.